This week on the Aviators, they're iconic, they're loud, and they're round. I head to Covington Aircraft to learn all about what makes a radial engine tick. And have you ever wondered what it takes for two airplanes to connect safely in midair? We're taking you inside a KC-135 at Tinker Air Force Base as we learn all about aerial refueling.
Aviators.
Few sounds in aviation create an emotional connection quite like the roar of a radial engine. For many people, radials conjure up images of World War II aircraft flying into battle. Others may associate them with biplanes doing acrobatic feats at air shows. Regardless, when an aircraft with a radial engine goes by, people take notice. Sadly, radial engines are no longer being produced by big engine manufacturers like Lycoming or Pratt & Whitney. But thanks to the dedicated work of engine maintenance and overhaul facilities such as Covington Aircraft, radial engines are staying in service for decades longer than their original engineers ever thought possible.
Well, Covington Aircraft began in 1972, so we've been around for a little over 40 years. And a guy by the name of Bob Covington founded the company, with my dad being one of the first 3 employees. And in 1975, my dad purchased Covington Aircraft from Bob Covington.
Aaron Abbott is the Executive Vice President of Covington Aircraft. As a family business, Aaron and his brother have taken up the responsibility of running the company which their parents built.
We're getting close to our 10,000th radial engine overhaul. We should hit that probably the first part of next year. So there's quite a few Covington engines out there. Now some of those have been overhauled and brought back into our shop at TBO, and then we overhaul them again. So there's some engines that we've overhauled multiple times, but all in all we're at about 10,000 overhauls.
Now looking at the 210, you may notice that the nose is anything but round. Packed under that cowling is a 6-cylinder horizontally opposed engine. That means I know absolutely nothing about radial engines, except they're round and they sound really cool. So to find out more, I took a tour of Covington's radial division with Rob Seaman.
So Rob, who are your customers here at Covington?
We have a lot of customers involved in the agricultural business. We also have customers in the warbird community. The big consumer of the 1340 is the T6 or Texan group. The Aeroshell acrobatic team is a big consumer of Covington engines. And we also do a large amount of float plane engine overhauls with the de Havilland Beaver and the de Havilland Otter.
So what happens in this particular part of the building?
This is our disassembly and receiving area. So engines, when we receive them, come in here, they receive a work order number that allows us to have traceability on the engine. And also a big part of the overhaul process is, of course, cleaning and getting the radial engine clean, which is a big task. And once that's accomplished, the engine as a whole is wheeled into inspection.
To inspect the engine's steel parts, Covington uses a process called MagnaFlux, which allows them to view cracks within the steel under a black light. Now, if you're like me, you're used to an aircraft engine that looks a lot more like this. 4 or more pistons in a row of 2 with a crankshaft in the middle. Or you might be familiar with a car or an airplane's engine where the cylinders are in a V shape. Either way, you're probably thinking, why the heck would they put cylinders in a giant circle?
On the radial engine, the bank of cylinders is on one single plane, which in turn, you have the crankshaft that has one throw, where your crankshaft has several throws depending on how many cylinders your engine has. Here we can see the crankshaft coming around, the cam moving, and also in the very back is the impeller, which turns 10 times the speed of the crankshaft.
At its core, a radial engine works the same way as any internal combustion engine. Fuel and air is mixed and then pumped into a cylinder, compressed and ignited, pushing the cylinder back toward the crankshaft. In this demonstration, this is all happening very slowly, but in a working engine, the crankshaft will rotate more than 2,000 times a minute.
One major advantage of the radial engine, besides simplicity, is the cylinders. The cylinders are air-cooled. There's two ways to cool an engine, whether it be liquid-cooled or air-cooled. Air-cooled is more advantageous for an aircraft of this vintage because the cylinders are out front, they're open, they can be cowled or uncowled. Also, the cylinders being out in the open, maintenance on the engine is very economical and mechanic-friendly.
Covington services two types of Pratt & Whitney radial engines. The R1340 Wasp, the first engine type Pratt & Whitney ever produced, and the smaller R985 Wasp Jr. These are two of the most popular radial engine designs and were used on many of the iconic aircraft of the 20s, 30s, and 40s, from the Ford Trimotor to the Lockheed Electra to the venerable T6 Texan. All of these aircraft featured a Wasp or Wasp Jr.
So Rob, how old are these engines?
Well, the very first radial engine was produced in 1925, and the last engine, which was a Wasp engine, 1340, was produced in 1969.
So it must not be easy to do the work that you do here.
No, there's a lot of reconditioning of parts. We don't have the luxury of going to a factory and ordering new parts, so we have to recondition parts and make parts usable again.
Covington maintains a large warehouse of engine parts and are constantly combing different resources for more. Pratt & Whitney stopped supporting their piston engines in the mid-1970s. Many of the new parts that Covington replaces during an overhaul may actually be 30 or 40 years old themselves, albeit still in their original packaging. However, sometimes Covington doesn't have new old parts to replace things with, so often has to recondition existing parts.
So when a part that you're working on needs servicing, you bring it in here to the machine shop.
Yeah, we have a lot of capabilities here in our machine shop. We have manual lathes and milling machines that we can go ahead and cut down a part as long as it's in Covington and Pratt & Whitney specifications.
Are you manufacturing new parts here when necessary?
We do manufacture some new parts. We're always working on repair processes and different approvals to allow us to give parts longer life or replace parts. Some of those parts would consist of 985 cams, the Wasp Jr., and also we're starting to develop the 1340 Wasp crankshaft, which is going to be a big, large part, but we're excited to tackle that, and I think that's next on our radar scope.
One of the most important parts of the engine are the cylinders themselves.
Okay. Here we are in the cylinder shop. This is where we prep cylinders for overhaul. What we're doing here is we're looking for any imperfections that need to be fixed and addressed before they start getting to be built. Cylinder fins can be broken out and built back up, welded up and addressed. So the mechanic here will find all the imperfections, and he hangs a tag on the cylinder with all the different things that he's found. That's kind of like a squawk list. And the welder, he'll go through those and he'll repair all the imperfections on the cylinder and give it back to the mechanic. The mechanic inspects it, and then he cleans it uses a sandblaster to clean the cylinder totally, and then it's ready for assembly, which all that work is done here.
So after all that work is done, how close to new are these cylinders?
Well, again, they've got a little bit of age on them, so they're reconditioned. We know that they're crack-free, imperfection-free.
So pretty darn close to new is as new as it's going to get, because how easy is it to get new cylinders?
Well, new cylinders are not available. They're not being produced. Pratt & Whitney, of course, stopped producing those back in the 60s and 70s, and there has been a few attempts at producing new cylinders, but nobody's making new cylinders now. So we're using the original Pratt & Whitney cylinder.
So this is it?
This is it.
Once all the parts of the engine have been refurbished, repaired, or replaced as necessary, the engine is reassembled. The engine then heads to the test cell to ensure that everything is functioning within specifications. All told, it can take 60 to 90 days to overhaul an engine to this state, where it looks as good or better than new. Now you look at this engine and the way it's assembled. I mean, I've seen engines. I'm by no means mechanical, but I mean, I know what an engine looks like.
Sure.
And there's just a certain appeal to this. It just looks different. I mean, just the way everything integrates with everything else. It looks like a very interesting puzzle almost.
Absolutely. It's almost like a Swiss watch. Everything, all the gears and rods and bearings are all tied together, and they all have to do their part to make the engine work. Again, we're dealing with 1925, 1930s technology here, and the days of CNC machining was not back then. So what we're dealing with is a lot of handwork, getting them in worn and bringing the engines back to life and back to the customer, and knowing that we've delivered a good part with integrity and dependability is very important to us.
Here at Covington Aircraft, we've been focused on 4 core values since we began in 1972. That's integrity, dependability, affordability, and quality service. And our number one value is integrity. If we don't get integrity right, if we don't do what we tell the customers we're going to do, then the other 3 really don't matter. When we tell the customer we're going to do something, we're committed to making that happen. We underpromise and overdeliver.
Over the years, as radial engines have become less common, many of Covington's customers have shifted to turboprop engines. Covington has shifted with them and is applying their same core values to servicing Pratt & Whitney PT6A engines. Now, there's a lot of advantages to the turboprop engines over radials. Parts are more readily available, fuel is more readily available, the time before overhaul is nearly doubled, and there can be substantial increases in horsepower just from the shape alone. But I gotta tell you, they don't have the same visual appeal, and of course, they don't have that same sound.
If they could make a PT6A engine sound like a radial engine, I think we'd have the perfect engine going. And our commitment is long-term to the radial engine. If you hear an aircraft flying over, whether it's a Cessna or a turbine aircraft, when it's flying over, people will look up. If they're aviation enthusiasts, they'll look up and watch it fly. But if they hear a radial engine, everybody looks up, whether they're invested in aviation or not, because the radial engine has such a cool sound. They'll look up to see what's in the air, and they'll watch it until they can't see anymore.
Hi, I'm Rob Ryder. Spend enough time watching the sky and you'll see a wide variety of aircraft. You'll see airplanes in a number of shapes and sizes. You might see a helicopter or a gyroplane with their rotary wings, or a glider soaring without power. You may see a weight shift controlled aircraft or a powered parachute. A balloon or an airship might also cross your path. Relaxing with a clear view of the sky can be a great way to pass the time.
With the launch of the B-52 in 1952, the U.S. gained a strategic bomber that could go higher and further than any bomber that had come before it. The threat of nuclear war meant that the U.S. had to keep these aircraft in the air as long as possible. This led to the need for a jet-powered aerial refueling aircraft. Boeing's answer was the KC-135. Developed from the same prototype as the 707, more than 800 KC-135s were built by Boeing between 1954 and 1965. While many upgrades have been made, including turbofans replacing most of the original jet engines, the KC-135 still forms the backbone of the Air Force's fleet of tanker aircraft. And of course, aerial refueling is no longer reserved just for bombers or large transport aircraft. Nearly every aircraft in the Air Force inventory is now capable of being refueled during flight.
Anywhere this aircraft is needed, because you figure less time on the ground, that's more time in the air.
Major Mark Povak is a KC-135 pilot with the 507th Air Refueling Wing at Tinker Air Force Base in Oklahoma.
So if we can get somebody across the United States and they don't have to stop, that's 2 to 3 hours. They're going to get that cargo there earlier. And overseas, we can have the fighters loiter or hang out and protect our troops. A C-130, the AC gunships, we can sit there and refuel them. They can hang out all night long versus, okay, it's time to get gas, you have to stop and go get gas. Now those guys on the ground are not protected. So as long as we can keep jets in the air, our guys on the ground are protected.
Today, in-air refueling is commonplace. The idea of extending an aircraft's range by refueling while airborne is a lot older than most people may think. The first in-air refueling took place in 1924. This consisted of one Army Air Service DH-4B biplane dropping a fuel hose to another biplane. It wasn't until the late 1940s that the two systems we see today were developed, the probe and drogue system and the flying boom.
This aircraft carries 3 primary crew members. Normally the left seat, just like an airline, the left seat's the captain, the right seat's the co-pilot, so you have pilot and co-pilot. The pilot, his main objective is to fly the aircraft. The co-pilot's talking on the radios, working the fuel panel. The boom operator, his main job is once we get there, he goes to work, refueling the other aircraft.
The boom is physically flown via the boom operator.
Master Sergeant Benjamin Brent is a boom operator on the KC-135 with the 465th Air Refueling Squadron.
The boom operator is positioned in the aft compartment of the aircraft in the boom pod, and the boom operator actually lays in a pallet. We'll step on down here into my office, and it's a little tight. You got 3 positions in here, so there's room for at least 6 or 7. We control the boom by a hydraulically operated ruddervator control stick, and we fly the boom with our right hand with the ruddervator control stick, and we extend the boom with our telescoping lever.
The refueling boom has 2 control surfaces which control both pitch and yaw, hence the term ruddervators. Since the boom operator uses these controls to fly the boom into another aircraft, they are responsible for ensuring that the entire refueling operation goes safely.
The boom operator is actually the person that establishes the contact. What happens is we will bring our receiver aircraft in to what we call pre-contact or astern position, which is approximately 50 feet aft of the extended boom. We extend the boom to 10 to 12 feet depending on the type of receiver. And then everything is very coordinated amongst myself, my pilots up front, as well as the receiver aircraft. And then when everybody's ready to proceed, then we clear the receiver aircraft into contact position, and he approaches approximately 1 foot per second closure until the boom operator actually establishes contact. So we actually fly the boom into the receptacle of the aircraft to receive the fuel.
The fuel receptacle is around 4 inches in diameter. This mates up with the 4-inch nozzle on the end of the boom. When fully extended, the boom is about 47 feet long. As you can imagine, successfully flying the boom into the receptacle is not an easy task.
Some boom operators kind of use the metaphor, you put a 40-foot pole in a 4-inch hole at 400 mile an hour. It takes a little bit of precision. It takes a little bit of skill. There's definitely some skill involved. It's not something you master on your first day on the job. But you know, like I said, everything is very coordinated. So as long as you know, we've got relatively smooth air and the systems are functioning properly, it's actually a pretty smooth process. It's actually not that difficult on a day-to-day, but it does take some skill.
The boom operator has a number of means to communicate with the receiving aircraft. On the bottom of the KC-135 are a series of pilot director lights which the boom operator can control from the boom pod. This can be helpful when conducting radio silent refueling. When not radio silent, both planes will use their usual radios to communicate, but some aircraft are able to receive interphone communication through the boom itself. Either way, precise communication is crucial, particularly when refueling another large aircraft.
As the bigger the aircraft comes up behind us, the more weight they create, just like in a boat. In front of a boat, you see that big mound of water? Same thing with air. They'll actually come up behind us and we'll feel our aircraft being pushed, and then they come through that bow wave and it becomes a low pressure, just like on a wing. The reason the wing flies is because of low pressure on top, so it sucks the wing up. There between the two airplanes, you get a low pressure, so it actually sucks them in. So it's a fine line between too much energy coming towards the other aircraft and enough just working the throttles, essentially like a gas pedal. The biggest thing with this aircraft is maintain stable platform for the receiver, because every movement that you make, he makes 3 movements. One to catch up to you, one to stop that movement, and then one to fix and stay still in that movement.
The position of the fuel receptacle on the receiving aircraft varies from model to model. On a lot of aircraft, the receptacle is directly behind the cockpit or canopy. This means the receiving pilot gets to watch the boom come directly toward them, then fly over their head.
You see that receiver flying, the receiver pilot flying, and he sees this, especially at night, when all they really see is that glow of that nozzle coming right over the top of their canopy or right over the top of their centerline window, and you kind of see them looking at it, and you see the whites of their eyes. He puts his trust fully into the boom operator, and basically not to tear up his aircraft, to bring that receiver into the envelope and establish contact and give that receiver the fuel that he's got to have to make it home or to make it to his destination, put bombs on target. So you got to think about the dynamic of what you're doing when you're refueling another airplane. You're actually going to put that boom in contact with another aircraft, physically in contact. At any moment, if something were to go wrong, you could become in contact. We're all trained to initiate the proper procedures so that doesn't happen. So, if our receiver does have excessive closure, or we're afraid that he may become too close, we're trained to disconnect from that aircraft and, clear the boom. And, if need arises, then we'll follow our emergency procedures of calling a breakaway and get a separation from that aircraft, and to mitigate any possibility of a mid-air.
The KC-135 can be adapted to do probe and drogue refueling with a hose and basket attached to the end of the flying boom. In this case, it's up to the pilot to fly into the basket and make contact. However, the boom operator is still watching the operation closely to ensure that separation is maintained and everything is safe. Along with the B-52 and the C-130, the KC-135 is one of the few aircraft that have been in service with the Air Force for more than 50 years. In the last decade, the KC-135 fleet has seen near constant use, not only as a refueling aircraft, but also for cargo and passenger transport. The aircraft is due to be replaced, but one thing's for sure, in-air refueling is not going anywhere.
Air refueling in support of the mission is absolutely paramount. If we did not have the KC-135, if we did not have tankers to execute air-to-air refueling, the mission simply just would not get done, especially in the expeditious manner that we get it done as we are as a world warfighter today. We just simply couldn't get the mission done in the way that we get it done. We could not support the troops on ground. We could not get fuel to that aircraft that needed to go to support our troops on the ground. It's absolutely paramount that we had air-to-air refueling.
Seasons 1 to 4 of The Aviators are now available on DVD and Blu-ray. For more information on today's segments, visit www.theaviators.tv. From our official home at the Whitman Regional Airport in Oshkosh, Wisconsin, we'll see you next week on The Aviators.